Okay, this is 7.1, inequalities in absolute value. So let's go ahead and start with a review of the inequality symbols. So this first one here is less than. So you might see something like 5 is less than 7. This next one here is greater than. Okay, so we might do x is greater than 10. Okay, so that would mean x could be any value, but it has to be bigger than 10, but not equal to 10. All right, and then this line underneath here for both of these means or equal to. So think about it as half of an equal sign. So this is greater than or equal to. So if I had x is greater than or equal to 10, that means x could be any value above 10 or it could include 10. And this is less than or equal to. All right, and this just means not equal to. All right, so let's look at translating these verbal phrases into an inequality. So the first one is Mr. Brust is broke. He has less than $9 in his wallet. Okay, so I'm going to pick a variable. How about B? Because we're talking about Mr. Brust. So B and $9. I'm going to put that to the side, leave some space for my inequality symbol. So Mr. Brust has less than 9. So think of a number that's less than 9. How about 8? Okay, kind of looks like a B too. So if I was comparing 8 and 9, right, I know it's elementary, but you always want to think about this as the mouth wants to eat the bigger number, right? So I'm going to have this as the alligator mouth eating the 9. So this is B is less than 9. And do I put the line underneath? No, I do not, because this doesn't indicate that he has 9. He is less than 9. Okay, so if I wanted to make this an inequality, I could just go, let's go ahead and put 9 here, 10 there, and 8 there. Okay, I would circle this number here. I would leave it open because there's not the line underneath, so it doesn't include 9. And Mr. Brus could have any value that is less than 9. Okay, so the line that we're writing is representing the variable. Okay, all right, next one. Kelly has no less than $5 in his wallet. So let's use K and 5. So he has no less than, so not less than 5. So he could have 6, 7, 50, doesn't matter. So let's say it was, I don't know, 60. Well, if we were comparing 60 and 5, we would want to, the mouth would want to eat the bigger number. Okay, so K is representing a bigger number than 5, and this has no less than, so no less than could also indicate that he could have 5. So we're going to put the line underneath here. All right, so if I were to plot this out here, do 5 here, 4 here, 6 there. I'm going to circle the number that I'm comparing. I'm going to shade it in because I have the line underneath, and I'm going to draw the arrow to the right because K is representing bigger numbers than 5. All right, and Kelly does not have $8. Okay, so this one is a little bit interesting. This one we would just be looking at 8, and we would keep this open, and this line would represent any value except for 8. Okay, so Kelly just doesn't have $8. We don't know if he has 9, 15, 6. He's in debt, $200. We don't know, but we know he does not have 8. So I would represent that graph like that. All right, so graphing inequality. So when do we have an open dot? When should it be closed? I went ahead and wrote out some steps for graphing inequalities. So number one, we want to circle the number that you're comparing. Number 2, determine if the circle is opened or closed. And 3, draw the line. Okay, bigger numbers are to the left, or sorry, to the right, and smaller numbers are to the left. So go ahead and pause the video, write these down in your margin. Okay, so let's use these steps to plot out these inequalities. So when you're not given a number line, I don't really care how you do this, just make sure you write the numbers in order. So make sure when we're talking about negative numbers, you need to have this going correctly. All right, so I got -8, -7, -6. All right, so what I want to do is number 1, circle the number that we're comparing. I'm going to circle -7. Number 2, determine if the number is open or closed. There is no line underneath this symbol. This is not greater than or equal to, it's just greater than. So we're going to keep it an open circle. And now I draw the line. So we want to look at the inequality statement, and this says x is greater than -7. Well, if the mouth is eating the x, that means that the x is greater than, and bigger numbers are to the right. So my line is shaded to the right. Okay. Next one, -7 is less than x. Okay, so let's do the same thing. -7 here, -8, and -6. Okay, we're going to circle the number that we're comparing. Determine if it's open or closed. Again, it is open because we don't have the line underneath here. Okay, and the mouth is eating the x. That means that the x must be bigger. So we shade to the right because bigger numbers are to the right. Okay, so as you can see, these are the same inequality, but it's different. The x is on the different side. Okay. All right, next one. G is less than or equal to 14. So let's start with 14. These are positive numbers, so 13, 14, 15. So step 1, circle the number that we're comparing. Determine if it's open or closed. We do have the line underneath this time, so this one is going to include 14, so we're going to shade in. All right, and the mouth is eating the 14. That means that the variable must be smaller. Smaller numbers go to the left. All right, and we've got pretty much the same thing here, variables on the other side. So we got 14, 15, 13 on the other side. Circle the number that we're comparing. We have the line underneath, so it includes 14. And this would say that 14 is greater than G, right? So G must be smaller. Smaller numbers go to the left. Okay? And let's see, H is not equal to -8. That's pretty much what we did up here. So I'll save the time there. I'm just going to go back up here really quick to the greater than or equal to. So we were talking about translating these verbal expressions. The greater than or equal to, you'll often see this as no less than, like we did with this example here. And then with less than or equal to, we'll see this as no more than. Just wanted to make sure I got that in. All right, moving on. Okay, so now we're looking at the opposite. So we're here, flipping it, we're looking at an inequality graphed out, and we need to write out the inequality. Okay, so what we do here is we pick a variable. So I'm going to just go x, and I'm going to compare it with 2, because that's the number that's circled. Okay. Now, the blue line represents the values of x. Okay, and so pick a number on that line. Let's go with -4. If we had -4 and +2, the mouth would want to eat the bigger number. And the bigger number here is the positive number. So the mouth is going to be eating the 2. So this is, we want x is less than, and then determine if it's open or closed. We have an open circle, so we are not going to put the line underneath. We're going to leave that alone. Okay, next one, x and -2. We could do this part first if you wanted to. So is the circle open or closed? This is closed, so we can do equal to. And now we can do the same thing again. Pick a number that represents x. Okay, so the blue line represents x. So just pick a number on there. I'm going to go with 4 again. So 4 and -2. Okay, well, which would the mouth want to eat? The bigger number, which is 4. So we want the greater than symbol. So now when we put it back into our inequality, this is x is greater than or equal to -2. All right, moving on. We're kind of squeezing absolute value into this because absolute value is really easy. It's just the distance a number is from 0 on a number line, and distance can't be negative, right? If you're driving in reverse, you're not going negative distance, okay? So the key to remember here is that absolute value is always, always, always positive. Okay, so one way to think about it is if we're at -3 and +3, all right, they're both the same distance from 0. 1, 2, 3, and +3 is also 1, 2, 3 units from 0. Okay, so we write absolute value as just these 2 vertical bars. Okay, this indicates absolute value. All right, moving on. So let's look at some more examples of these. Okay, so find the absolute value of, let's see, how about we do -0.5. Okay, these absolute value simply mean the distance from 0. So the absolute value of -0.5 is positive 0.5. Okay, what about the absolute value of 1/2? A lot of students get this confused and they start thinking that absolute value just starts, that it means the opposite. It doesn't mean the opposite, it's just always positive. So the absolute value of 1/2 is 1/2. All right, super easy, so doesn't even matter. Pick a number, absolute value of 126, positive 126. All right, absolute value of -3/4, positive 3/4. Okay, see, it's not hard, it's just always, always positive. Okay, one thing that does trick up students sometimes if you have a negative on the outside. So let's say we have a negative and times the absolute value of -10. So what we do here is we take the absolute value of -10, which is positive 10, and then you think about this as just dropping out in front of it. So that then makes the positive 10 negative. Okay, another way to think about that is like -1 times the absolute value of -10. Okay, all right, so how about these? What if I have the absolute value of x is equal to +5? Well, what are the values that x could be? We know that the absolute value of -5 is +5, but so is +5. So x could either be -5 or +5. Okay? We could switch up the variable. Y is equal to +4. So what could be the values of y? We could have 4 or -4. Okay, one way I like to think about absolute value as a washing machine, right? So you can put in dirty clothes and they come out clean or positive, but you can also put in clean clothes and they come out of the absolute value bars also clean. Okay, so that's how you keep it straight from. They're not opposite. It's just always positive. Okay, so what if you have a problem like this? Z the absolute value is z is equal to -3. So hopefully you're recognizing this is a little confusing because nothing can come out of these absolute value bars as negative. So we don't have an answer. When we don't have an answer, we just write no solution. Okay. All right, that's all I have for you guys this week. So why don't you guys give the practice problems a shot? If you're struggling, make sure you watch my help with practice problems video.